In this video, I'm going to demonstrate how to perform the chi-square goodness of fit test. So in this data we're working with here, you can see we've got responses to several different questions. So this was a survey given to a group of college athletes, and they were surveyed on various aspects of their, mostly their sleep health and their training. So we have gender, age, the season their sport is in, the number of hours they train, the number of hours they sleep. And so each respondent was given an opportunity to pick a category in which their sleep, for example, fell, or the number of hours of training fell. And so what we're going to do here is we're going to try and determine if we're going to work with the sleep variable here, is if the number of people that responded in each of those categories is significantly different from each other. So is there a difference in the number of people that responded 6 to 8 hours of sleep versus 8 to 10 versus 10 plus, or versus less than 6? So, numerically there might be a difference, but we want to be able to see if that difference we're seeing is systematic. In other words, is it significantly different, or is there a statistically significant effect somewhere that's explaining this difference versus just random differences we might see in how people respond to this particular question. So in order to do that, we're going to perform this chi-square goodness of fit test. And so in order to do this, we're working with one variable that has any number of possible categories that people could fit into within this variable. And we're going to determine if there is a significant difference among the category frequencies. And so with the chi-square test, what it's essentially doing is looking at the expected frequencies we might see in each category. So if we have 28 subjects and we've got, I believe it's 4 categories, then there should be, if there's no effect, if there's not a significant effect, the null hypothesis would be the same number of people would end up being in each category. And so that's what's known as the expected frequencies. And so we have obtained frequencies here, and we're going to compare our obtained frequencies to the expected frequencies and see if there is a trend indicating that there are differences, and these differences are likely not random or due to chance. So that's what we're essentially going to be able to do, is make that determination. So let's go to the analysis menu, and we're going to choose the non-parametric menu, and we're going to find the chi-square goodness of fit test. We're going to select that. And so since we're only working with one variable, we just need to add the variable that we're interested in. In this case, it's sleep. And then we're going to go ahead and click confirm on that. And then we're going to click calculate. And so the output we're going to get is fairly simple. And we're going to go ahead and look at the raw output. And so what we can see here is a frequency table. So because we had 28 people, the expected frequencies for 4 categories was 7 people in each category. So that's essentially our null hypothesis, is that there would be 7 people in each category if there was no effect. And so we also see the observed frequencies, and we can see that there are differences between the expected and the observed, but what we want to determine is if those differences are statistically significant. And so that's where the chi-square value comes in. And so we can see the chi-square value here reported. It's 13.7. And we can see the p-value associated with that chi-square value. And we can see that it's 0.003. So if we were testing the null hypothesis that there would be no effect on the category frequencies at a p less than 0.05, we can see here that this value is less than 0.05. And so we would be able to reject the null hypothesis and say that there is a significant difference in how people are categorizing themselves and choosing these particular categories. And we can see that the most frequent choice is 6 to 8, and the least frequent choice is less than 6 and more than 10. And this difference we're seeing here, based upon this p-value, we can make the conclusion that this difference is not likely due to chance, but is likely due to true differences that among these individuals as far as the number of hours that they sleep. So that's how we can run the chi-square goodness of fit test. And again, you can do this for any number of potential categories. In this case, we had 4 categories, but we can do this for any number of potential categories. So hopefully you found this video useful, and good luck using it in your own research.